Hello guys, and thank you for watching this video lecture. Today we are going to study SQL window functions. SQL window functions allow us to perform calculations across a set of rows related to the current row without collapsing the result set into a single output, like what we had already for aggregate functions. The window functions are used to compute running totals, rankings, moving average, and other analytical metrics within a specific window of rows defined by the our clause, which can include partitioning and ordering. For example, functions like row number, rank, sum, and average can be applied over a window to assign rank, or we can calculate cumulative values while preserving the individual row in the result set. This makes window functions ideal for tasks like generating leaderboards, analyzing trends, or comparing values within groups. And in this way, they offer flexibility and precision in data analysis without the need for complex subqueries or joins. In this lecture, we will study the use of SQL window functions like row number, rank, dense rank, partition by, order by, running total, moving average, and lead and lag functions. Like the previous lecture, our examples are based on university schema with 11 tables like student, department, takes, advisor, course, prerequisite, section, instructor, time slot, and classroom. So if you want to see a list of our tables, select all from information schema.tables. So here we can see a list of tables and views that we already generated. So in case of tables, we can see classroom, department, course, instructor, time slot, and other tables. So let's start learning window functions. Window functions perform calculations across a set of rows related to the current row without collapsing the result set. There are some components here like partition by, order by, and a set of window functions. Partition by divides the result set into partitions, or you can say groups, where the window function is applied independently. Then we have order by. This order by specifies the order of rows within each partition for the window function, and we have a set of window functions like row number, rank, dense rank, sum, average, lead, lag, and others. So we're gonna start with ranking functions. We have row number, rank, and dense rank. Ranking functions assign a rank or a number to each row within a partition. Row number is used to assign a unique sequential number to each row, even for ties. Then we have rank. The rank is used to assign the same rank to tied rows, but skips subsequent ranks. And then we have dense rank that assigns the same rank to tied rows, but does not skip ranks. So for example, I want to do ranking instructors by their salary within each department. It means I want to rank instructors based on their salary within each department, right? So select from instructor and let's rename this one as I. All right, so let's go here. Then I dot name. I want to have name, I dot department name, I dot salary, right? Then in here, row number, right? The first one is row number. So row number over, then here, partition by department name, because we want to have based on department, right? Department name, and then order by based on salary in a descending mode. And we can select a name for it, for example, row underscore now. Next, I want to go for ranking, rank over, then the same here. Here, partition by department name, order by salary in descending, and I want to call it as rank. Next, the third column is dense rank. I will show you what is the difference between dense rank and rank. Our partition by department name, order by salary, descending mode, and as dense rank. All right, from instructor, here add one order by based on department name and salary in a descending mode. Okay, that's all. Let's try this one. So from the comma should not be here. All right, so you can see here, we have several departments. In the biology, we have only one professor, so row number, rank, and dense rank is the same. Then in the case of computer science, you can see we have 5 teachers, right? The first one is 92,000, so row number 1. You can see here in this department 1, 2, 3, 4, 5. So no meaning, just sequence number. Then we have rank. So 92,000 is rank number 1. So dense rank is the same rank number 1. The second one is 75,000, rank number 2, dense rank number 2. Then here we have two professors with the same salary, right? So their rank is the same, right? So 3, 3. 3, 3. And here is the difference between rank and dense rank. In the case of rank, we don't have 4. The next one will be 5 because we have 2, 3 rank here. But in case of dense rank, the next one will be 4, and these two will be considered as 1, right? Then we have for electrical engineering, both same. We have for finance, same. The others are almost same, right? But only case was here that this is the difference between row number, you can see sequentially. In rank, we have 1, 2, 3, no 4, then 5. But in here, 1, 2, and these two are considered at 3, and the last one will be 5. We do partition by department. It means group rows by department. Order by salary. These orders rows within each department by salary. But this one is for general one. This one is for each department. Then we have row number. The row number assign a unique row number 1, 2, 3, 4, 5 till n for each one. The rank assigns the same rank for equal salaries, skipping the subsequent rank. And the dense rank assigns the same rank for equal salaries, but rank continues sequentially. This is the difference between rank and dense rank. The next example is ranking courses by credit within each department. I want to write a query which ranks courses by the number of credits within each department, right? So select from course as C. Also here I can add that department name is not null, right? And then I will order by the result, the total result based on department name and credits in a descending mode, right? So here, what I'm interested in, C.title, C.department name, and C.credits. Okay, then here, row number, other partition by department name, order by credits in a descending mode, and we rename it as row underscore num, right? Comma here, then the same here, and the same here without comma. This one will be rank, other partition by department name, order by credits, descending as rank, and dense rank here, other partition by department name, order by credits, and as dense underscore rank. All right, so let's try this one. You can see this query rank courses by the number of credits in each department. So you can see here in biology, we have these 3. So 1, 1, 3, in here 1, 1, 2, right? This is the difference. And this is for computer science and the rest. Partition by department name, group courses by department, the order by credits, rank courses by credit, highest first, and then we filter out courses with null department here to avoid invalid partitions. Next, I'm gonna rank students based on total credits. Select from student as S and order by total credits in a descending mode, right? Now here, I'm interested in s.name, s.total credits, and in here, I want to calculate row number, other, so here, order by total credits, and I call it as row number. Then rank, other, order by total credit, and in a descending mode, here also in a descending mode, as rank, and also dense rank our order by total credits in a descending mode as dense rank. So it's okay. Let's try some error. This one. Yeah, I forget to add this too. So it's okay now. In this example, you can see here all are the same because we don't have any two students with the same total credit. So, and in this example, compared to here, we don't have partition by because we want to rank all students together based on the total credit. In here, we wanted to have the output based on each department, but in here, we want to have for all students, right? Not in each department. That's why we don't have partition by. So then we have order by here. This order by total credit in the descending mode, orders by total credit. It means highest first. So the next example is I want to numbering course sections by semester and year. It means I want to write a query that assigns a row number to each section of course within each semester and year. So select from section, and here I want to order by course ID, semester, year, and section ID. That's okay. So what should be in the result? Course ID should be there, section ID should be there, semester should be there, year should be there, and we're gonna have one row number. So row number our partition by course ID, semester, year, then order by section ID, and we're gonna rename it as section underscore number, right? So let's try. We can see that for courses like Bio 101 in fall 2004, we have three different sections right here, 1, 2, 3, and then we added some this section number 1, 2, 3. But for others, we have 1, 1, 1, right? Again, in here for CS 190, we have two sections, so it added 1 and 2 here. The partition by course ID, semester and year, group sections by course, semester and year. Then the order by section ID assign row numbers based on section ID within each partition. The next example is ordering instructors by salary within department. So I'm gonna write a query that lists instructors with their salary rank within their department, right? So select from instructor, then their depth name is not null, and I'm gonna order by department name and salary in a descending mode, right? So what attributes should be their name, department name, salary, and here I'm gonna have a dense rank function over partition by department name, order by salary in a descending mode, and we rename it as salary underscore rank, right? So let's try this one. Okay, so in biology department, this Professor Greek is rank number 1. But in the case of computer science, we have 5 professors. Rank number 1 is Brandt. His salary is 92,000, rank number 1. Then we have Kutz, 75,000, rank number 2. Then Professor Kim and Professor Srinivas, they have both same salary, so they are rank number 3 together. And Professor Park is 60,000, rank number 4. So in here, partition by department name, groups by department name. Then order by salary in descending mode ranks instructors by salary within each department. And then this dense rank function ensures no gaps in rank numbers for ties. And also we filter out null departments for valid partitioning. Next, counting courses per department with ordering. This query is going to count courses per department and also assign a rank based on the number of credits, right? So select from course as C. We want to filter out the null department. Department name is not null. Order by them based on department name and credits. Course. Okay. So what attributes should be there? C dot department name, C dot title, C dot credits, and here count all over partition by department underscore name, and we're gonna rename it as course underscore count. This count star is the standard SQL syntax for counting all rows in a group, including those with null values in any column within the window defined by the order clause. Then we're gonna use rank function, rank over, then partition by department underscore name, order by credits in a descending mode as credit rank. So let's try this one. Very good. So here, this count star, our partition by department name, this counts courses in each department. Then the rank, our partition by department name, order by credit in descending mode, ranks courses by credits within each department. And then we combine an aggregate window function of count with ranking function of rank together, right? We can see counts of courses per department. So biology, like 3, computer science, like 5, and also we have ranks, etc. The next one is running totals. Running totals calculate cumulative sum over a set of rows, often using sum with a window specification. The running total allows you to track the cumulative value up to the current row within a defined group or order. For example, I'm gonna find running total for department budget. I'm gonna write a query to calculate a running total of department budget, and then I wanna order by budget size. Select from department, and then I want to order by based on budget in a descending mode, right? So here, department name and budget. Then in here, sum of budget. Then our order by budget in a descending mode. Then rows between unbounded preceding and current row as running underscore total, right? So let's try this one. Very good. This sum budget over, this computes the cumulative sum of budgets. And then order by budget in a descending mode to order departments based on their budget. It means highest will be first. Then here we have rows between unbounded preceding and current row. This includes all rows from the start to the current row. So in the result, you can see here, this is running total. So 120,000, 120,000. Then the next one is sum of these two, right? So 100 and 120 is 220. Then this one is sum of these three, right? So it will be 120, 190, or you can say 90 plus this one, right? Then this one is this one plus this one. It means sum of all previous one. This one is sum of these two, this one is sum of these two, and this one is sum of these two. This is called as running total. Next, I'm gonna find running total of student credits by department, right? So select from student as is, then their department name is not null, and I'm gonna order by them based on department name and total credit in a descending order, right? So here, I'm interested in S dot name, S dot department name, and S dot total credits. I'm gonna write a code for running total, right? Sum based on total credits, then over partition by department name, order by total credits in a descending order, rows between unbounded preceding and current row. We can call it as running sum, okay? Then let's try this one. Very good. So in each department, right? So for the biology department, we have only this, right? It's okay. For the computer science department, 102, 102, 102 plus 58, 160, right? And this one plus 160, 214. This one plus this one here, right? So for each department-wise, we can see the result. The next example, I want to find the running total of course credits per department. It means this query will calculate the cumulative sum of course credits for each department, right? Select from course as C, where department name is not null, and I'm gonna order by them based on department name and credits in a descending mode, right? Then here I'm gonna get department name, title, and C dot credits. Then in here, sum C dot credits over partition by depth underscore name, order by credits in a descending mode, rows between unbounded preceding and current row as running underscore credits. Great. Let's try. Very good. So in here, we found the running total for course credit per department. So biology, you can see you have 4, then next is 8. It means 4 plus 4 is 8. This 8 plus 3 is 11. It means 4 plus 4 plus 3 is 11, right? For computer science, 4, 4. 4 plus 4, 8. 4 plus 4 plus 3, 11. Altogether, 14 and 17 here. We have something like this one for the moving average. Moving average calculates the average of a value over a specific window of rows, often used for smoothing data trends. So I'm gonna find the moving average of instructor salaries. So this query is going to calculate a 3-row moving average of instructor salaries per each department, right? Not for all. So select from instructor, then where department name is not null, and I'm gonna order by them based on department name and salary in a descending order. Very good. Then in here, I'm gonna have name, department name, salary, because I'm gonna get this output with 2 decimal places. So I use cast round. This is just for that 2 decimal places. Then average, right? Cast salary as decimal 10 and 2 over, then in here partition by department underscore name, order by salary in a descending mode, and rows between 1 preceding and 1 following, then 2 as decimal 10 and 2 in here as moving average salary. Okay, right? So all right. So this one is for one professor, it's okay. But in the case of computer science, you can see here, this is the average salary. It means 92,075, right? 83,000. So in here, 92 plus 75 divided by 2 is 83.5 that you can see here, right? Then for the next one, it will be 92 plus 75 plus 65 divided by 3. You can see 77.3, right? For the next one, it will be 75 plus 65 plus 65 divided by 3. It is 68. And for the next one, we're gonna have 65 plus 65 plus 60 divided by 3 is 63.33, right? And the next one is only for these two because we don't have anyone here. So the next one is 65 plus 60 divided by 2 is 62.5. This is how running average works. The next one, I'm gonna write a query for moving average of student credits. Again, 3-row moving average, okay? So select from student where depth name is not null, order by department name, total credit in a descending mode. So in here, I'm gonna get name, department name, and total credit. Then in here, average, total credit over partition by depth underscore name, order by total underscore credit in a descending mode. This comma should not be here. Descending mode, then rows between one preceding and one following. Right? Between one preceding and one following, right? It's correct. From okay, so here we need to close this one and we name it moving average credits. Okay, correct. So again here, this is for each department. Biology is 120. Again here 102 and 58. So let's see. 102 plus 58 divided by 2, 80. Then 102 plus 58 plus 54 is this one divided by 3 is 71, right? And so on for the rest. This is moving average. The next one, I'm gonna apply moving average for course credits, right? Select from course where department name is not null, then order by depth, department name, and credits in a descending mode. Very good. Here, title, department name, credits, and then average credits over partition by depth underscore name, order by credits, order by credits in a descending mode, then rows between one preceding and one following, right? And we can rename this one as moving average credits. Good. Try. Okay, here you go. You can see the credits with moving average for each department. The last topic here is lead and lag functions. Lead function assesses the next row value and lag assesses the previous row value within a window. For example, I'm going to compare instructor salaries with the next and previous salary in their department. Select from instructor where department name is not null and order by based on department name and salary in a descending mode. Name, department, name, salary. So lag function will get salary, right? This lag retrieves the previous row's salary, right? So other partition by department name, order by salary in a descending mode as previous salary. We rename it as previous salary. Then we do the same thing for lead, right? For the next one. So lead salary over partition by, and we name it as next, right? Okay, let's try. So you can see here, so we have group by professors based on department, then we order by based on their salary in each department. Then the lag retrieves the previous row salary and lead retrieves the next row salary. So in the case of biology, we have one, so both of them are null. In the case of computer science department, this Professor Brand is the first one, so we don't have previous, but the next one is 75,000. Because it's in order, it means a little bit less or maybe equal. Then we have Cat with 75,000. Previous one was 92,000, and the next one is 65,000. Then we have Professor Kim, 65,000. The previous one was 75. The next one is 65. Then we have Srinivas, his salary is 65,000. The previous one was 65. The next one is 60,000. And in here we have next one as null because computer science is finished here. And then we have electrical engineering department. Okay, that's all for today. In today's lecture, we learned the key SQL window functions based on the university database. We tried row number, rank, tenth rank for assigning rank within groups. We tried partition by and order by for defining groups and ordering within windows. Then we tried running totals for cumulative sum of our ordered rows. Next, we tried moving average for smoothing data trends over a window. And finally, we tried lead and lag functions for assessing values from adjacent rows. Okay, so please practice these examples and feel free to ask me your questions by leaving a comment below this video lecture. Thank you very much and see you in the next lecture.